Hey, hi. So basically, see, your proper system is completed. Whatever you have shared now, that is the same. So basically, we have used the same data set which I shared you initially to for that I shared you initially, right? This is the same data set. So I'll share you this collab link as well as a file. Okay. So what you have to do, you have to go to file section and you have to click to open notebook folder. Okay, open notebook, and here you have to select the file whatever I will share you. Okay, then you can have this kind of a proper code in your collab. Okay, and you no need to do the training as I have already done the training, so you can directly run the live prediction code. Okay, so I'll just explain you the code key, what is the code about. Okay, so here you can see, here we are downloading the data set, here we are importing the libraries, here we are reading the data set, whatever data set we have, here we are providing printing some info related to data set. So data set having almost 60,000 rows. Okay, with respect to the different types of malwares, spyware, trojan, uh, normal attacks. Okay, so this is the basic statistics of the particular data set, and we are checking missing value, so there is no missing value, data set very clean. Okay, and what we see, there are two types of labels are there, subtype and label. Label is just having key whether the particular row is normal or malware. Okay, so but in subtype having four category: normal, meaning spyware, ransomware, trojan. So I feel instead of labels we should use this one because it has more category. So what I have done, I have removed the label column and made this subtype as a label. Okay, because it is more informative. Okay, and here we are printing some correlation with respect to the labels, subtype labels. It is the correlation. Okay, with related to process matrix. Okay, and this is related to there are some list of categories labels are there. Okay, so I am just printing, I was just checking the uh, value range key, was just like this is the particular column are there. Okay, so what is the range bound that particular column having? So this is the range bound. Okay, so similarly here are some more correlation with some different parameters. Okay, so this is the spyware range for that particular column. Okay, for this column. So I was just checking key, if ransomware is the class, then what is the range of this column in this particular this is the range of this particular area. So it helps for analysis purpose. Okay, so this way we have done some analysis, and then we are identifying key very less correlated columns so that we can remove it. Okay, so these are the two very correlated columns, so which is no use of making prediction with this. Okay, so we are removing this two column, as well as we are removing file raw type. Okay, so basically this is the file name, so we don't need any file name, right? And also removing the label. Okay, and using subtype as a label. Okay, and after that then we are doing the label encoding. In the label encoding we are assigning begin as a 0, ransomware as a 1, spyware as a 2. Okay, so we are basically replacing the labels into number because algorithm need numbers data, not a label data, right? And here we are printing some bar graph, pie chart related to classes. Okay, and then we are doing the label encoding, saving the label data, and then we are taking dividing data set into x and y. X is basically input, y will be our output. Output means ki type of label, and rest columns will be input. Okay, and here we are identifying top 20 features. Okay, and then we are printing the top 20 feature of algorithm data set, because data set having 54 columns, so there is no use. Okay, so we have identified top 20 columns and we are using the same. Okay, so as you can see, this is the complete column features, so there is a very less correlation, 0.01, very less, right? So no use of the using that. Okay, so these are the top 20 columns which we should use for the algorithm training. And then we are dividing data into training and testing part, 80 into 20 ratio. 80 we are taking as a training, 20 we are taking as a testing. Okay, and this is the function which I have created to print the complete correlation matrix of the algorithm. Okay, so first algorithm which we have used is decision tree. So for the decision tree, the accuracy is less. Okay, 72%. and remaining informations are there. F1 is core recall and precision, everything. Okay, and then we have used random forest. So random forest we have got around 90% plus accuracy, around 90. Okay, which is very good. Okay, and then we have used knn we have got 80%, just 80%, and then the Gaussian blur, this is also very less accurate. Okay, and then what we have done, we have made this staking classifier. Is a kind of a combination of multiple algorithms. So in this staking ensemble model, what we have done, we have combined all the three algorithms which we have trained, and with the ensemble model, then we are making the prediction. Okay, still it is 86% accurate, so not good as a random forest. So then we are saving the particular train model into a file. Okay, and then we are checking the prediction with the particular model. So prediction is very accurate, pretty accurate. Okay, whatever class, it's just like this, the class 2 feature, class 2 related inputs. So output is also the class 2. Okay, so which is working very fine. Okay, so similarly, then we are randomly, I what I'm doing, I'm exporting some random samples from dataset in the CSV format to testing purpose. Okay, similarly, we have done deep learning algorithms as well. We have used a CNN algorithm. Okay, so for CNN we have got less accuracy, and then we have used LSTM plus neural network. Okay, there also we have got less accuracy, because this is a label based problem, CSC based problem, right? So machine learning algorithm always play good always gives good accuracy in CSV database label dataset. So neural network is basically designed for image related operation, so we don't have this image, right? So obviously machine learning will perform well. So still LSTM performs 66% accuracy, which is less. So one of these random forest is based, which is give the 90, around 90 accuracy. So in the live prediction we have used the same. So in live prediction code we are downloading the model, whatever the model we have. Okay, and then I have written the code for live prediction where we are loading the model, and these are the columns which need to take the input and displaying the welcome message, then making the prediction with live input. Okay, whenever you will run this particular code, just let me run this. Okay, so let me run this. So it will ask you to select the input type, like whether you want to go for manual input or CSV based. So suppose I want to make it CSV based, so I can then choose a file. Just like I have some files like class 2 related file. Okay, so you can just upload the file, and you will get the prediction. Okay, whatever rows in that particular CSV file. Suppose there is the first row. So in the first row, predicted class is 2. Okay, which is spyware, which is basically a pretty correct result, right? Because it is class 2 result, class 2 CSV file. Similarly, I have provided some random files, so you can just test with these different files. Okay, and you can have the prediction. Okay, so yeah, this is about your system.
If you're in doubt, then you can comment in the comment section. I will try to reply soon. And thank you friends for watching my video. If you are new, then subscribe channel and share with your friend.